Hello and welcome to the third episode of Tech Nuggets and Thoughts. I am Nikhil Vanpal, one of your hosts. We today also have a few more hosts for this episode. Why don't you guys introduce yourselves?
Okay, I'm Christian Kuya. I'm CEO of Nelkinder Softwarecraft, and I wrote the first line of code in 1984.
Hi, my name is
Hi.
Siddesh. I work with Christian. I am a co-founder of Jigsaw Software Craft.
Hi, I am Mandar. I work with users and I am non-tech here. I am the only odd man out, it seems.
Well, 1984, I wasn't even born. So. Alright, so today's topic of discussion is circular dependency in software. So, what is circular dependency? In terms of classes, if class A depends on class B and in turn class B depends on class A, then we can say that these two classes have circular dependency on each other. And the problem specifically is that we cannot resolve all dependencies of class A without resolving dependencies of class B. And again, class B depends on class A, so we cannot resolve all dependencies of class B without resolving class A's dependencies.
I think classes are a good example that circular dependencies can be bad, but they are not always bad. There are a few problems where circular dependencies kind of appear naturally. For example, if we have in Java class string extends object, it's a dependency. Class string extends object and therefore depends on object. And class object has a method string to string, which returns a string. So class object depends on string. So we have a circular dependency between class object and class string. And I think Java is going to give us a lot of examples about circular dependencies, some of which are okay-ish. I think this one is okay, and some of which are not.
Right. Then what are the circular dependencies that are not okay?
From the API, I think we might find some, but out of the top of my head, I currently can't find. I can tell you what I think where it's starting to get bad. If I have two classes and they're in the same package, and the circular dependency is between those two classes that are in the same package, then from the outside, the impact of that circular dependency on me as a user of one of these classes is limited. It's contained to that package. But as soon as a circular dependency crosses package boundaries, then it infects packages. If I have a class in one package and a class in another package, and they depend on each other,
Right.
then the packages start to have a circular dependency. What's the effect of that?
So if we wanted to make modifications to one class in a package, it will have impact across package into another package, leading to a whole lot of modifications or refactoring to make smaller changes.
Exactly. And that leads me to one of the topics that I took into my notes. I haven't looked into that in detail, but what I do know is that the Java Jigsaw project, which was released with Java 9, should actually have been released much earlier, and it took a very long time, and I suspect that circular dependencies between packages were one of the headaches of the Jigsaw team. What we also can see is that if we look at the module structure in Java that we now got with Java 9, it is not a one-to-one picture of the package structure, but some modules contain multiple packages. For example, there are circular dependencies between Java Lang and Java Util, and there are circular dependencies between Java Lang and Java Lang Reflect. So some of these circular dependencies have forced the Jigsaw team to group packages before they made modules, and that also had a consequence. The Java team had to introduce a new language concept in Java 9, which is the modules.
Right. This is actually interesting. It reminds me of another use case, but inter-process dependency. So we had kind of a microservices stack. It's too vague a term to call it so, but okay, there were two processes running for an application, and one process depended on the other, and the other process depended on this one. Then we faced a lot of deployment issues, we faced a lot of refactoring issues, maintenance issues, and the conclusion or the quick solution to this was to merge those processes into one. Probably something similar to what Java did with modules uh, to resolve the circular dependencies of packages.
Exactly. So when we look at circular dependencies, I think just roughly, when we try to paint it black and white, we can say there's good ones, there's bad ones. And as I already said, string object, I'm kind of okay with that. Although it could be solved in a different way, but I'm kind of still okay with that. Because as a user, it usually doesn't impact me. Another example is the composite design pattern, which you use, for example, for showing tree structures and directories and stuff. Like a directory is a file, and the directory contains file, so it's bidirectional dependency. So sometimes you have things where circular dependencies occur naturally. I find it okay if the responsibilities are very close to each other, and things which have very close responsibility should be close to each other, because there's a few synonyms for responsibility. For example, we say responsibility is reason for change, and things that change together, we also call them cohesive.
Yes.
And when we talk about coupling, we talk about the dependency that propagates change. And then when we talk about a circular dependency, we talk about coupling that propagates change in a circle. Have your fun with it.
Nice. That was actually very well put.
So for common man understanding, can I say if the dependency is contained within a block, reusable block, now that block could be module, that block could be something else, then that dependency is something that we can live with.
Yes. If that containment, so well, it depends on what is the scope of the containment, yeah. But if you say your block has a certain limited size, yes.
Problems with circular dependency arise because when you want to refactor one part of it, it may or may not have something related to the part that that depends on this directly. But just because there is a dependency in a circular fashion, the other part also has to be modified, also has to be deployed. So it kind of creates a whole lot of modifications for things that are relatively small, or they could have been changed with little refactoring. And it applies to, applies to each level. Maybe class, maybe module, maybe package, maybe module, even process. So the impact or effect is similar, but is different in all these levels. So at class level, the problem is maybe when you refactor, your IDE will take care of it. Probably something like IntelliJ is really good at finding dependencies and making modifications to all the dependent classes when you change a name or a variable or a method. So when it comes to but the problem arises when you leave a particular code base and the dependency is between processes. There isn't any existing tool that can detect circular dependencies or help you modify dependent code automatically when something like this changes. So that brings to another point. Actually, there is no tool today to detect circular dependencies in microservices.
We can look at log files and analyze them with scripts. If we have things like the API gateway applying session IDs or request IDs, or actually request IDs, not session IDs, so that each request coming in is unique and can be identified in the log file. And then if we see the inter-service calls appearing back and forth with the same request ID, we can see the consequences of circular microservice dependencies by analysis, but I don't know of a tool that can be applied at construction time.
Yeah, there isn't one. So we could use Zipkin to see the call flow, and maybe we can build something on top of Zipkin to determine if a particular call has circular flows or a particular microservices have circular dependencies. But that's at runtime. And again, it also depends on your sample size. So what if the particular call flow that has circular dependency was not invoked for the duration of log that you collected? You'll not see it.
Yeah.
So,
You need
I
to
have
have
a question, like whatever you mentioned about the impact of changing one thing will also have an impact on the other thing. So that will exist in normal dependencies as well, right? Like,
Well, yeah, that's true. So you will always have dependencies. It's inevitable, yeah, because things have to use each other. That's dependencies. And you will always have a direction of dependency that we call coupling, which is the propagation of change. So if I change this, I will, as a consequence, also have to change that. The problem with a circular dependency, as Nikhil already mentioned, when he called it code bases, or when we call it release entities, Java jars or wars, or Go binaries and libraries and things like that, it can make you feel like in a bad bureaucracy. So making a change is like filling a form. And then if you want to fill that form, the person behind the counter tells you, but if before I can actually approve that form, you have to bring me another form from another counter. And then you go to that other counter, and they send you to the next counter and the next counter until you reach the origin counter where you're coming from.
so it increases the code smell viscosity.
It actually, thanks for mentioning a design smell, we're going to talk about that shortly. But imagine that you have a library that you release independently. So you give it a version number. And then you have another library that depends on this version. So you make it, and they depend on each other. So you change that library, you make a release, now you have to change the other library and make a release, now you're going to have to change this library and make a release. So you basically, for releasing and having stable versions, circular dependencies put you in an infinite loop of release.
this will also cause problems during deployment. It's like a chicken and egg problem. So when you are bringing up the stack, what comes first? So if you had a clean dependency graph, the lowermost the lowermost dependencies should be brought up first and the highermost dependencies later. And once everything is up, the stack is running. But if you were to deploy something, the component that you are deploying depends on another component, and the circular dependency is going to cause problems because there will always be a state till both components are fully deployed that some calls may not work correctly.
Yep.
Nikhil, but you mentioned like lowermost dependency and highermost dependency. If there's no tool that can detect dependency, how do we decide which is lowermost dependency and highermost dependency thing?
That's a good question. So that's actually job of software architecture. So if you have your dependencies in code, you can analyze the source code for the dependencies. If you don't, then you have to collect the dependencies manually as an architect and draw a dependency graph. So you might have your different services, also your third-party services, and so on. And then what you should have in your microservices landscape, actually in any landscape, no matter what it is, you should have a diagram that shows you the structural decomposition of your system and contains all the arrows, and then you just look at the diagram to see is there any circular dependencies. So in the diagram you will then have like up and down, top and bottom. In the simple say, let's just simple service, on the bottom you might have the database, in the middle you have the service, and on the top you have the UI, like your web app. Yeah? And as soon as you carve out different services because you want to release them independently, you want to sell them independently as different services, or because of scalability. There's so many reasons why you might carve out services. Then the number of arrows grows with the number of boxes. And then you have to make sure that there's no circles, because otherwise you get the problems that we already mentioned.
So having a UML diagram would already be of quite help.
Yes, it doesn't have to be UML, but of course UML is our lingua franca for describing such things.
Having a diagram and sticking to it.
Oh yes, yeah. Which is there's a bit of a sidetrack, but well, I love good architecture documentation. The good architecture documentation for me is short. If someone shows me a document that is 300 pages, I know that probably no one is reading it. We don't have the time for reading and maintaining 300 pages. Or maybe if people are reading it, they're reading it, but they're not trusting it. It's going to be out of date. If it's just one picture, I'm going to have a high amount of trust, because it's easy to just keep one picture up to date.
But I heard this somewhere that you should not look into the design before developing. The design should be evolved. You can probably so
that's also an interesting question. So I think with the whole agile movement and softwarecraft movement, I feel we reached to an agreement that big design upfront doesn't work. But I feel sometimes people are now going in the other extreme, which I find also wrong, which is the no design upfront. You should at least have some bit of a vision and a metaphor and sketch out a few blocks. Maybe those blocks are going to change a lot in the first weeks there, and that's okay, because it means learning. But you should have at least some vision so that the different team members can do aligned work without stepping on each other's feet.
So maybe the role or goal of the architecture has changed, but I agree that it has not gone away. Before we start coding, we have to have some idea of what we want to code. So we can't just upfront start with hello world and reach to a web application just like that. We have to know where we want to go, what are the components in it, how they should interact. Maybe the components will change, maybe the interactions will change, but some idea about the goal is what should this diagram capture.
So a high level idea.
Yes, high level. What I would probably not do any time is recommend people to, for each requirement that they have, do a design document first. I find that ridiculous. It also is a misunderstanding about design, in my opinion. I think design is an artifact and not, well, it's also an activity, but the value of design is actually the artifact created, and the artifact created by design is the code. The code is the design. I mean, that's I think a good topic for another podcast, so I'll leave it at this point. Maybe people will disagree, but that's hopefully going to make you curious about the next podcasts that are going to come.
Yeah. Well, to bring it back to the topic, Siddesh mentioned about the design smell, viscosity that may be caused by circular dependency. So what do we have to say about that?
Well, the term viscosity in the context of design is coming from a group of design smell categories, and I think all four of them will also have circular dependencies as their drivers. So the four design smells that I'm talking about, they are rigidity. That means that code is just hard to change. You want to change something in one place, and for that you also have to make changes in other places. And how is it that if you want to change one place, you also have to change another place? It is because of coupling, a dependency that propagates change. The next one is fragility. So you make a change in one place, and something elsewhere in the system breaks. How can it be that we're making a change in one place and something else breaks? There must be some change transporting dependency. So again, coupling.
So that's unknown effort, right? Fragility is unknown effort, rigidity is known effort.
Very good point.
Yeah.
They are related to project management. So rigidity is something that is easily knowable. Maybe I don't know it up front, but I can start making the changes, and then something like the compiler or also my tests are gonna tell me. And that means it is knowable effort, therefore normal effort in project management terms. So fragility regarding project management means risk, because so I change something and something else breaks, which means that I should have changed something else as well, but me developer, I didn't know, because if I would have known, I would of course changed it. So I didn't change it, which means it's risk, unknown effort.
So fragility by nature is not class dependency or something that the compiler cannot detect?
Well, if the compiler would tell me, I would have to change it, therefore it would be rigidity.
Right.
And there was a strong argument in the 90s between the community that said we don't need strong typing, like Smalltalk, and then later Ruby, and the community that said we need strong typing, like C++ and Java. They claim that types are the solution to turn fragility into rigidity. I strictly disagree with that. I'm a big fan of types in large projects, and if I would have to deal with a significant amount of JavaScript code, I would prefer TypeScript.
Yes,
Yep.
I totally agree. So, there's another thought. I mean, interestingly, with Spring's qualifiers in place, it creates a coupling that is built into strings, because we are declaring the dependency we want and name of the dependency we want. So unless our IDE is capable of actually understanding the framework and detecting that there's a dependency, there may not be a compiler error.
Yes. I think there's two things to this. So one thing is that I think we should not trust types solving all these issues in terms of fragility versus rigidity, because types can't find everything. I still find types useful, but types are not the only way how to figure out that something is wrong. Unit tests are also a way. By writing unit tests, what I do is I also turn fragility into rigidity. Instead of not knowing that I broke something, I will know that I broke something. Therefore, I turn fragility into rigidity. It doesn't matter to me whether it was the compiler telling me or the unit test telling me. What matters to me is that I got fast feedback about the consequences of change. And the other aspect is, which is then linked to that, so Spring tries to sometimes go the opposite direction of types. Yeah, what you've described, Nikhil, is basically the opposite of direction of types, turning compile time errors into runtime errors. And I think that Spring does it because in some situations this might be useful, because sometimes I wanted something that the compiler could find, that the compiler doesn't find, but my runtimes find, in order to decouple, that I can develop independently.
Okay. Interesting.
It doesn't mean that it's always a good thing, yeah? But that's engineering. Yeah? Weighing the pros and cons, finding the balance, making an informed decision.
Right. Okay. Just another thought. How will our unit tests help us detect if there was a change or if there was a dependency on something and that changed, if it is somewhere else, like the code base is different?
I completely agree with that. Yeah, that the unit test will not find, because if I change something in this code base and it impacts something in another code base, my unit test will not find. I need an integration or acceptance test for that.
Did we finish all the design sprints?
No, we did not. Very good. So, just one more word about unit test. So, just to make sure that when I say unit test, that the audience actually is on the same page with what I mean. For me, a unit test is not something that tests something in isolation. For me, a unit test is a test that runs fast, that gives me fast feedback. And whether that test is written with JUnit or Cucumber, and whether that test is calling a method or is calling an API, or is running through the UI, is not of primary significance to me. The fast feedback is of primary significance to me.
So by that definition, all tests written with Spring tests are not unit tests.
I actually agree with that. I agree with that, yeah, because Spring makes your tests slow, and that is one of the things I totally hate about Spring. There's so many good things about Spring, but this one is something I totally dislike.
Actually, this is just to add to this. I was interacting with automation QA team and had a very interesting insight. Like we refer to unit tests as unit tests, and the scale or the size of unit test or scope of unit test depends on what we define as a unit. So this is a revelation I had when I was interacting with them. To them, a unit test was everything that developer writes, and what we call as integration tests, where all classes interact with each other, to them that was insignificant. To them, they meant that all components interacting with each other is an integration test, and everything that happens inside the component is unit test. So we are, as a developer, breaking that component further into classes and packages or modules, and then referring to those individual tests as unit tests and bringing them together as integration tests. It was just a view, like the other side of the code would look at it as still as a unit.
Yep. So I use a different definition of all these terms. The definition that I use of these terms is coming from Mike Cohn's test automation pyramid, which he published in his 2008 book Succeeding with Agile, plus spiced with Robert C. Martin's tweets. So the three main layers, and of course it's something that for your project you have to tailor. The three main layers that I distinguish are acceptance tests, which are written by and for or on behalf of users. Integration tests, which are written by and for or on behalf of architects, and unit tests, which are written by and for or on behalf of developers. For me, the isolation of units is actually the wrong track, and we missed the point in history at which we should have renamed unit tests to something else. But so for me, the word unit test regarding the intention that we want to achieve today is misleading. Isolation of classes is for me the wrong track, but I think that's again a good topic for another podcast. Siddharth reminded us to complete the list of the design smells.
Yes.
So we had two of them, fragility and rigidity. Rigidity meaning it's hard to change. Effort. Fragility means that there's risk of change. Immobility is one specific form of rigidity, you could say. It means that something is not reusable. Let's say you have login in your system, and your system is a forum, and then your next project is a shop, and you also need login. Can you reuse login from your forum in your shop? That again is influenced by coupling. How much is login decoupled from the other things? And again, of course, circular dependencies play a role because they are an even worse form of coupling than regular coupling.
Yeah. So again, to the first point of defining the modules. If we want to take login, we'll also have to take whatever it depends on in a circular fashion into the next project.
Exactly. And that can include a lot of things that we actually don't want or need.
Right.
And that means that we're going to have effort cutting those dependencies. And then cutting those dependencies can actually introduce risks. When we talk about testing, there's two interesting aspects about this, in this particular context. One of them is what does decoupled actually mean? It means that I do not have a dependency that propagates change. But having fewer dependencies and having dependencies only pointing in one direction, unidirectional dependencies, also makes code more testable. It turns out that testable and decoupled are actually synonymous. And same goes for reusable and independent developable and independent deployable, which again is something we already mentioned in the context of circular dependencies. Deployment difficulties caused by circular dependencies.
Just to point out, copy paste is not reuse, right?
Exactly. That's why I actually say it's spelled COPYPEST.
Yeah.
The other aspect about testing is, I try to not say too much, otherwise I'm going to give away too much from our next podcast. Tests shall help development. They shall make development faster by giving us courage, by removing fear.
Yes, I so much agree with you. Sorry to interrupt. Yes, go on.
Please, you can interrupt me anytime. Because I think whenever you try to interrupt me, you have a very interesting thought. So please don't hold yourself back.
This is a point that it is very hard to convince people, and especially management, that testing makes us fast. Because testing makes us fast when we consider iterations, not a single delivery. And that's a change in the perspective when we look at testing. So yes, it gives us courage to change. It gives us reliability that whatever happens, I can freely make modifications to the code in whatever sense I want, and it will still not break the functionality. That is the guarantee that it gives me, and that is the reliability that I can deliver my code with. And it's amazing when we consider that in grand scheme of things.
I'm sure that some people in the audience will now say, but our tests take 2 weeks to run. And yes, they might, but it doesn't mean that our tests take 2 weeks to run. Our tests run fast. And if you want to learn how your tests can be fast as well, then you have to tune in into the next podcasts.
Okay. So
the other thing about tests is, and it's closely related to what you've just mentioned about risk management and thinking about it in iterations. So, and whether that has to be taken into account or not is something that you have to figure out for your particular project. What if you reuse parts, but you followed my advice to the world that unit testing is no longer about units? It's still a bit about units, but the level of unit that you should think about is, what are things that you would probably, in a long run and an ideal world, reuse independently?
yes.
I think that is the level of unit that you should be looking at. For example, if you have a composite pattern, class file and class directory, and they depend on each other, you would probably not reuse them independently. They are intrinsically coupled. That's a natural form of coupling. That's one of these examples where even a circular dependency is okay.
Right.
And that is something that you can test together, and you're going to reuse it together. You're not going to reuse any of those in isolation. So that's fine.
Right. So just another example of a graph data structure would have a node and an edge. An edge would have a node, and node will have a list of edges.
Yeah.
So it's a circular dependency, but there's no point in separating the edge and the node from each other, and it makes sense to have it that way.
Exactly. Yeah. Because, we actually have deficiencies in our languages that appear the more we use them, the more experience we gain. I mean, software development is still a very young profession. If we think of it, we can take Alan Turing as the first developer. And we can say, okay, Ada Lovelace was the first developer. I agree with that. But then he was the second. There was no others. Let's take him as a point. How many developers are there today on the planet? We know it's millions.
Yeah.
I don't know if it's 5 million, 10 million, 20 million, but we know it's millions. What growth is that? So Alan Turing, 1944, first developer, one man, creating a team, and now we are millions. Yeah? it means that there is a growth curve where maybe it doubled like every 4 years, every 5 years. What does it say about our average experience in our industry? It means that half of our industry have fewer than 5 years of experience.
Right.
That's why we hope that we make these podcasts for a good reason and for a good use.
Yes.
That we share our experience.
Okay. So, going back to the point, how do we detect if we have a circular dependency?
I think we
We've
already talked
covered
about
part of
the microservices. It's still a bit of a tool gap there. Between packages and classes within one project, tools like IntelliJ IDEA can give you very good feedback, or if you're a C# developer, use Rider.
SonarQube is a really good tool that can tell us about circular dependencies, among other things.
Yeah.
And it also tracks how the health of the project is increasing. It can also detect dependencies and reuse across services and
Yeah.
code bases.
I actually don't like SonarQube, but that's another topic for a podcast. And please keep your SonarQube running. Just because I said I don't like it doesn't mean it's bad. But there's just a better way even. Only disable your SonarQube if you have the better way.
Just moving on to the next point. So how do we solve a circular dependency at all the levels that we discussed? So I'll just take the first jab. So if it is about classes, then I think in general the principle would be to extract common things into another component. So whatever level it is. So if it is at class level, maybe extract out the common things into another class and make both classes depend on this class.
Can we split this question into two phases? One is you are figuring out circular dependency before deployment,
Right.
and you figuring out that there is a circular dependency after deployment once your application is popular. Lots of people are using it.
Okay.
I think the process will remain the same. That's a gut answer. Yeah, I haven't given this question much thought yet. It's an interesting question. So my feeling is that where your product is in its market life cycle will probably not have a strong influence on your approach towards circular dependencies, except for one thing. When you're a startup, there might be a phase where, because when we talk about circular dependencies and all the bad stuff and so on, we're actually talking of a form of technical debt.
Yeah.
And technical debt is like a loan. You have terms and conditions applied to it. Just that with technical debt, they can be very weird. There can be technical debt where you don't pay any interest rate, but the payback increases over time. There can be technical debt where it decreases over time. There can be technical debt where the payback is very low, but the interest rate is high. That's of course technical debt you try to address very quickly, very early on. But why do we take technical debt? Sometimes, of course, because of ignorance, because we don't know better, because we don't have the experience. But sometimes also we might be taking technical debt because of a proper business decision. Sometimes we maybe talk with our product owner, say, approach A, quick but dirty, approach B, clean but takes a little bit longer. And when we talk about small things in code, I don't believe in that. I always go for the clean. But as soon as dependencies come into the picture, we're talking of bigger things. And there might be situations where taking technical debt might totally make business sense. Where you take technical debt where you say, okay, we know this is a circular dependency and it's going to take us some time to cut it, but currently the interest rate that we have to pay is very low because we only have like 20 users, and if the system is down for a few minutes for deployment because of the circular dependency, it doesn't matter a lot to our users. Then 2 weeks later, you're popular, you have 1 million users, and every single second of downtime is going to be reported on Twitter. Yeah? In that case, you're going to start caring about it. That's when you try to pay it back, where you have to break the dependencies.
Right. So, in a way, we are saying that it depends on how the circular dependency is going to impact our business. We will have to make a call if and when to address it.
Yes.
Okay.
And there's two aspects of the business. There's the business aspect that is visible to the business, like deployment time getting longer and longer. Sooner or later, that will be visible to business. And there's something which is maybe not so visible to business, which is it's slowing us down in development. Yeah? That's not necessarily directly visible to business. Every day, I'm making changes in the field of the circular dependency. There's a chance it impacts me and it slows me down.
Yeah.
And day by day, that also might grow. And that is where I have to take a call and say, well, business doesn't see the impact, but I feel the impact on my desk, on my keyboard, in my brain every day. So I'm taking a call to fix it.
Eventually, business will see this as a loss of productivity.
Yeah, yes, the productivity gap.
Yeah. Of course, by then there'll be whole other reasons as well contributing to this, but this will be among them. So, yeah.
But the productivity gap can be difficult for business to spot and address, because business relies on us engineers being the professionals, and it could be that the productivity gap comes because we are not behaving professional enough.
Yes.
But I think we still have some ground to cover about how do we deal with circular dependencies. Yeah? We had, Nikhil, you suggested that we identify redundancy and extract it into common classes as one of the approaches to dealing with that.
Yes. So, I think the same would apply to all levels. That's my thinking, of course. So I think if we say that identify the common things and extract them out into a dependent component. If we generalize this applies to classes. This applies to services even. So,
Yes.
say a service has a dependency. There's essentially a third service in the making that will be dependent upon by both the previous services. Essentially breaking the circular dependency and making them unidirectional towards this new service.
Which means following the single responsibility
Yes.
principle. Yeah. So in the original paper, Principles of Object-Oriented Class Design, Robert C. Martin described in the original paper. In the original, it was actually not present. It was in the second or third version of the paper. He described it as a class should have only one reason for change, which again connects to what we already said earlier, that responsibility is reason for change. It's a very interesting definition, but I actually think the SRP is, as you said, much more universal. It does not apply to only classes. I like to phrase it slightly differently. I say every entity in a software system, on its level of abstraction, should only have one reason for change. And that entity, that could be even just an expression or a line of code or a function or a type or a class or a data structure or a package or a module or a service or an entire software. Of course, they have different levels of abstraction, but on their level of abstraction, they should have only one reason for change.
Yeah. Actually, even Robert C. Martin discussed this point in his book Clean Architecture, that he picked SRP principle that was mentioned in Clean Code, and actually he discusses how it applies to an architecture across components. Of course, the like you mentioned, the abstraction level is different, but the principle at heart remains the same.
Yeah.
So, yeah.
There's something interesting in general about these principles. So all these principles, not only the SRP, all the 11 surprise solid principles, that's 5 principles for classes and 6 principles for packages, help us dealing with cyclic dependencies. And one of these principles explicitly talks about them, which is the ADP, the acyclic dependencies principle. And it says that dependencies between packages must not form cycles. When Java breaks this, we know that there are circular dependencies between Java packages, But that's why Java had to introduce modules, and modules in Java should not have circular dependencies.
Yeah, so that's what we are saying today. We'll
Yes.
see what happens for a period of time, like what we
Yeah,
saw in class.
let's see. But I think so. We know that there are some principles that come and go. Some things that we learn, they change.
Yeah.
Like, for example, isolation of units in unit testing. Right? So it's no longer about isolation. Sometimes we still isolate and break dependencies in unit tests to speed them up, but in general, unit testing is no longer about isolation. It's just developer tests. Fast feedback. So some principles come and go. Some principles are here to stay. I think acyclic dependencies principle is a principle that's here to stay. And I know that there's a whole community around the language that completely agrees with that, which is Go. Because the Go compiler prevents circular dependencies. You can't compile Go code that has circular dependencies between packages. The compiler simply refuses.
Wow. Okay. So, how do they detect by loading or by passing the STL compile time itself?
The Go compiler is very fast. Actually, the Java compiler is also quite fast. Most people don't know how fast it is because they use shitty tools like Maven or Gradle around it. And I admit I'm one of them due to the lack of faster tools. But the Go compiler, a lot of things that in Java, because we didn't know when we developed Java, had offloaded to other external tools like dependency management and build automations integrated in the Go compiler. That makes it very fast. So in Go, you simply compile the entire stuff in one go. In the background, the Go compiler caches stuff, but it means virtually the Go compiler, when you compile Go code, sees everything. It sees the entire thing, the entire source code, including your third-party libraries.
Okay.
And that's how it detects the circular dependencies. It immediately knows. Another way how to break dependencies is by dependency inversion. When you invert dependencies, you will still have a dependency, but if you have a circle, all you need to find is one of the arrows that you can flip around.
Right. Exactly. That's the reason for existence of dependency inversion is to flip around the arrows to make sure that the dependency flows in one direction, and that we do by extracting interfaces.
Exactly. And so I guess that a lot of our listeners are Java developers, C# developers, Ruby, maybe Go, JavaScript. But I also want to connect with people who write in languages like C or C++. Whatever we are talking about applies to those languages as well, even assembly. If you want to find an example for the dependency inversion principle in action in C, look at the qsort library function from the C standard library. You find dependency inversion in its finest form from the early 70s. There's one particular form of dependency that I hate very, very much, that I also want to talk about. That is a function calling another function and that other function calling that first function, which is basically a ping-pong recursion. I totally hate that. I'm a big fan of recursion, but I hate ping-pong recursion. It is so error-prone. How do you determine termination of the recursion if you have a ping-pong between two functions?
Because I think that's probably the only way we can simulate tail recursion in Java or even JavaScript. Since we do not have tail recursion, we essentially have to put it on a event loop by doing a set timeout in JavaScript. And
okay, again, there are exceptions. Yeah, I completely agree. There are exceptions, but I think that's a very controlled and well-defined exception that follows a pattern.
And this ping pong thing, is that an actual technical term? Ping pong calling function?
No, I just made it up. I just call
Okay.
it ping pong. So normally when we say ping pong, we are actually talking about a special combination of pair programming with test-driven development. So that it means something entirely different. But I guess most people know ping pong, and therefore
Yes,
will
yes.
still be able to relate when I say ping pong function calls. I think you still get the picture.
Yes.
Okay.
Okay, I think Siddharth, you had a question about.
Yeah. So can we avoid circular dependency in the first place? Is there a way you can detect it early or avoid it? Like, is there a way? Could TDD be useful?
So let's answer your last point first. TDD is always useful, and it's also useful to avoid circular dependencies, because TDD requires that you write the test first and you force yourself to have decoupled code. There are so many benefits of TDD, but forcing us to have a decoupled and therefore good quality architecture is one of them. It's very hard to accidentally write circular dependencies if you're doing test-driven development. It's very difficult to do that. So test-driven development helps us avoiding circular dependencies.
Yes, and I think another tool that we did discuss, IntelliJ IDEA, does highlight the cyclic dependencies in the dependency viewer.
Yes.
So we will know about circular dependencies while we are actually creating them.
Exactly, but people, for that you have to use the dependency viewer. Please, it's there, use it. There are a lot of tools that we can use in our projects in order to achieve quality, like Sonar Cube, Sonar Lint, IntelliJ IDEA inspections, Checkstyle, PMD, Find Bugs. So there's the Java tools, but other languages also have tools, like C has PCLint and Splint and so on. And other languages have other tools. Go has GoLint, for example. People use these tools, and please don't use these tools at the end of your project. Use them from day one. You don't want to put yourself in a situation where you have a project, you have a project plan, you know you're going to take 8 months for this project. In the last 2 weeks you say, oh, but actually we have to deliver quality, so let's activate these tools. And then you discover what all mess you made. You want to don't make mess, prevent mess. Use these tools from day one.
Yeah, so in very agile with a capital A term, this would be the sprint zero task, setting up the tool set to help development.
Yes. And document your development guidelines, document your coding guidelines. Also keep them short. Ideally the coding guidelines are not you have to run this tool and that tool and that tool and that tool and that tool, but ideally they are just run this script. And that script should run all these tools, and the script should pass. Yeah. All of them, like Jenkins has to be green.
Yeah.
And Jenkins has to run all these. Or whatever your integration server is.
Yeah.
And as a side note, please use Jenkins 2 and please use Jenkins file and please put Jenkins file into source control. And if you still use Jenkins 1, please upgrade.
Okay, I think we are nearing end of our discussion. So, do we have any parting thoughts or summary that we should?
So, as a non-tech person, when I was hearing what you people were talking, an image came to my mind, an image of a person who has a disease without any visible symptoms. So, for me, circular dependencies, that kind of thing, which may not be very apparent, but the disease is there, it's there. You do not know when that will break your software system.
I like that picture.
Yeah, actually.
Because they can hide themselves quite well for quite a while. If you go back to Java, they have been hiding themselves from the public view for like 20 years. 95 to 2015.
No offense to Java developers, we love you.
Yeah, it could be misunderstood what I said. I think the Java team has done an awesome job, and it's just a matter of that our industry is still so young. Many of the mistakes that we see that Java made are not made out of stupidity. They are made out of lack of experience of our industry. We are still evolving. We are still discovering. we don't even know if we've already found all programming paradigms, which would yet be another interesting podcast.
Right, that's it. So, this is Nikhil signing out. Bye bye.
Christian signing out. Bye. Thanks for listening.
So this signing out. Bye bye. See you soon.
Mandar signing out. Bye bye. See you very soon.
You can follow us on Tech Nuggets and Thoughts on Twitter. It is TECHNGGETS on Twitter.
You can find me, Christian, on Twitter with @CHRISTIANHUJER, Christian Huya.
You can find me, Nikhil, on Twitter as Nikhil1 @Nikhil1pal, NIKHILWANPAL.
You can find me on Twitter at Mandar MANDR THOSAR.
So you can find me on Twitter as well. It's Siddesh Nikode. It's SIDDHESHNIKUD. So love animals, love environment.
Okay, love the people who love animals because these people are not really bad.
That's actually deep.
2 levels deep.
Better software, better world.
Drive safe when you're outside.
And don't forget to floss.